Hello everyone and welcome back to this video on TheCodeBakery. So in this video I'm going to be discussing the solution to USACO 2020 US Open problem 1, which is social distancing. So I'll leave the problem statement in the description below, and I highly recommend that you guys first check out this problem and then try to solve it for yourself before watching this video. So yeah, I'll leave the problem link in the description. So I'm going to discuss the answer to this solution. I'm going to this problem. So the main thing to note here is that the number line can be really long because it can be up to like the length of 10 to the 18th. And if you were to try to do something like brute forcing each value of d, that definitely wouldn't be able to work for the test cases 4 through 10. It could probably work for this test case 2 to 3, but in this case, the number line is too long to do the brute force. So instead, we have to do binary searching. So, and the main thing to know is that if, for example, we know that a value of d fits this criteria such that each cow is at least a distance d apart from another cow on the number line, then we know for a fact that each value less than d will also be able to fit this criteria. Similarly, if we know that a value of d doesn't fit the criteria, such that cows can fit on the number line, then values larger than d will also not be able to solve the problem. So we can binary search to see what value of d will work. So then we have to create like a check function to see whether a certain value of d will work or not. And then once we do that, that is essentially like the solution. So the check function, and one like common use of this like binary search is that if you binary search, typically you can be able to find a simple way to determine whether a value works. In this case, you can greedily put the cows on the number line to fit as many cows as possible, because you want to try to put them such that their two cows are just a distance d apart. You don't want to go like any like larger if you can. So I'm kind of going to simulate the check function for a couple different ones for this problem. So in this case, we have to place 5 cows on the number line, and I have them right here. So I will try first for like a distance of 1 apart. So we first put 1, and we're always trying to be like greedy. So like we try to put a cow on the first one, which we can, then the next one, so at the space 1, we can also put it, because these are 1 apart. And then we can also put it at 2, because all of these are now 1 apart. And now we put it at the next available space, and we can put it right here. Now we put this at the next available space, so this will be at the 5th index, and we see that, okay, we have put 5 cows, we can just say that this check is true. So what about if d is actually equal to 3? So similarly, we place it at the earliest available space that we can, so at 0, and then we say, okay, the next available space should be at 3, but there's nothing at 3, so we put it at the next part, so 4. Now we can put it at the next one, so 4 plus 3 is 7, so it can be right here. And then the next one should be 10, but there's no space for 10, such that we can put the cow to graze on grass. Therefore, a 3 wouldn't fit the criteria. And so we know that any value above 3 would also not work. Similarly, in the previous example, when I said 1, we know that, well, I mean, 0 would, I guess, work, but I don't think that we can have d 0. And they state in the in here that a solution with d is greater than 0 is guaranteed. So finally, I'll just also show like what if we were to do 2. So again, we put the cow at the earliest possible space that we can, so 0, and then the next earliest possible space is a 2, so we place it here. Then the next one would be a 4, we place it here. The next one is a 6, so we place it here. And the next one would be an 8. There's no 8, but there's a 9, so we place it here. This would be 5 cows, and this would fit the criteria. So now I'm just going to briefly show the code I used. Okay. So you can see that the main thing is just like, oh yeah, also it's important that you sort the points, or you sort the intervals based off like increasing order. So that way you can do the greedy algorithm to check. So you can see that we're just printing out the binary search, and yeah, so the binary search is just a really simple thing. It's just initialize a low and a high, and then if the check is true, then we know that if the check is true, this means that we set the value of d to be middle, and in this case, we know that any value below this middle value will also work. So we don't need to check those values again. Similarly, for if it's false, then we know that every value above that value of d will not work, and we don't need to check that. And then here's the main part. It's just like this check. So in this case, we essentially say how many like cows we can place down, which I put as covered, and then we essentially go through the number line and say, okay, is the last cow that we placed down plus the middle, if that's in the current grazing interval, then we know that we can just place that cow down there, or else we're going to say that the grazing interval will be at the next part. So if I go back to here, these grazing intervals would be like 0 to 2, 4 to 7, and 9. And of course, if we can place the number of cows, then we just return true. And also, okay, I don't think I really explained this part well. So the main thing is that we keep this last point as where was the last cow that we placed down, and then we want to check whether the next cow is still in our current grazing interval. So, and that's why I keep an index variable to say, okay, what grazing interval are we looking at right now? So if the next point is still in our current interval, then we can increment our covered and say that, okay, the next cow is at this point. I'll get to why I use this max later. Or else, if the next cow is not at our current grazing interval, then we have to increment our index. And the reason why I use this max is because I never really changed this last point. So if we increment our grazing interval, then the next cow would be placed at this point right here. It's like when I did this, tried this for 2, I essentially said, okay, our last point is at 6, but then it should be at 8, the next cow, but that would be last point plus middle, 8 would be greater than this 7 right here, so it goes through this index plus plus, and then when we check it again, so is 8 less than or equal to this, the next grazing interval end, which is 9, that would be true. And last point, it would be, if I didn't have this max, it would be at 8, but it should actually be at this 9, so the beginning of the next grazing interval. So that's why I do that. And yeah, that's essentially the entire solution. I'll put this code in the description below so you guys can check that out. So thanks for watching this video on the Code Bakery, and I hope that you guys can watch others too. Thanks.